At the base of Mount Fuji, inside a windowless factory painted entirely in bright yellow, a fleet of industrial robots is building other industrial robots. There are no workers on the floor, no lights, no heating, no air conditioning. These machines have been running in total darkness, unsupervised, for 30 days straight. The company that built them controls half the computer-controlled machine tools on Earth, and if you have ever driven an American car, held an iPhone, or taken a pill from a plastic bottle, their equipment made it. But almost nobody outside of manufacturing has ever heard their name. This is Trade Archive. If stories like this are why you're here, take a second to like and subscribe, because this one runs deep. In the autumn of 1946, a 21-year-old engineer named Seiuemon Inaba walked through the doors of Fujitsu Manufacturing in Tokyo. He had just graduated from the University of Tokyo with an engineering degree 2 months earlier, and Japan was still rebuilding from the ashes of the war. Fujitsu, which would later rename itself Fujitsu, was a telecommunications company trying to find its footing in a demolished industrial landscape. Inaba was quiet, intensely focused, and obsessed with machines. He would spend the next decade working in relative obscurity inside the company. But in 1955, Fujitsu made a decision that would alter the trajectory of global manufacturing forever. The company wanted to explore a technology called numerical control. At the time, every lathe, every milling machine, every press on a factory floor was operated by a human being turning hand wheels and reading dials. The work was grueling, it was slow, and the tolerances depended entirely on the skill and fatigue level of the operator standing in front of the machine. Numerical control promised to change all of that by using encoded instructions, initially punched into paper tape, to direct the motors inside machine tools automatically. Fujitsu assembled a team of 500 engineers and put Inaba, now 30 years old, in charge. Within a year, his team produced something Japan had never seen before. In 1956, they built the country's first successful electro-hydraulic pulse motor and the first working numerical control prototype. It was a proof of concept that automated precision could actually work at an industrial scale. By 1958, the team shipped their first commercial NC unit to Makino Milling Machine Company, one of Japan's leading machine tool builders. The system worked. Makino ordered more. Throughout the 1960s, Inaba's division kept pushing. They moved from simple positioning control, where the machine moved to a fixed point and stopped, to contouring control, where the cutting tool could trace complex curved shapes through metal. This was the leap that mattered. It meant an automated machine could carve an engine block or a turbine blade, not just drill a row of holes. Japan was racing to industrialize, and Inaba's team was building the nervous system for the country's factories. By the early 1970s, the technology had evolved into what the industry now calls computer numerical control, or CNC. The punched tape was replaced by onboard computers running a standardized programming language called G-code, and Inaba's division had grown so large and so profitable that it no longer made sense to keep it buried inside a telecommunications company. In 1972, Fujitsu spun the division off as its own entity. They called it Fujitsu FANUC, an acronym for Fuji Automatic Numerical Control. Inaba, now 47 years old, became its executive director. But Inaba was not content to simply dominate the CNC market. He understood that the real leverage was in controlling the machines that loaded and unloaded those CNC tools. The physical arms that moved raw metal into position, closed the machine doors, and pulled the finished parts out. In 1974, FANUC developed and installed its first industrial robots in its own factories. The company was no longer just making the brains of the factory floor, it was making the hands too. And then Inaba did something that no one in the global business community expected. He closed FANUC's Tokyo headquarters and relocated the entire operation to the deep forests of Oshino Village, a remote settlement at the foot of Mount Fuji in Yamanashi Prefecture. He claimed that precise technology could only be born in places with clean air. But industry insiders understood the real reason. Inaba wanted total isolation. From competitors, from journalists, from anyone who might learn how his machines worked. The compound he built was enormous. 1.78 million square meters of dense forest, cleared in strategic patches to make room for over 20 windowless factories and dozens of office buildings. And every surface, every wall, every robotic arm, every employee uniform, every company vehicle, even the sleeves on the chopsticks in the cafeteria, was painted the same intense shade of bright yellow. Inaba stated plainly that in the Orient, yellow is the emperor's color. The message was not subtle. Inside the compound, Inaba ran FANUC like a sovereign state. He forbade subordinates from speaking at executive meetings unless spoken to. He reportedly banned his engineers from reading external technical journals, believing that outside knowledge would contaminate their original thinking. The company had no investor relations department, no quarterly earnings calls, no public relations office. For decades, FANUC conducted multi-million-dollar business deals by fax, refusing to use email because Inaba feared computer viruses would compromise his technology. The global financial community started calling him the Yellow Kaiser of Mount Fuji. He did not seem to mind. But while Inaba was building his fortress in Japan, a crisis was unfolding 6,000 miles away on the factory floors of Detroit, Michigan. By the early 1980s, America's big three automakers, General Motors, Ford, and Chrysler, were hemorrhaging market share to Japanese imports. Toyota, Honda, and Datsun were producing cars that were cheaper, more fuel efficient, and dramatically more reliable than anything coming out of Michigan. The American consumer had noticed, and the American auto worker was paying the price. General Motors, the largest of the three, was losing billions. Its new chief executive officer, Roger Smith, believed he had identified the solution. If Japanese companies could build better cars with fewer defects, it was because their factories were more automated. Smith concluded that General Motors needed to automate aggressively, not just to improve quality, but to reduce what the company viewed as unsustainable union labor costs. The problem was that America's domestic robotics industry was fragmented, underfunded, and nowhere near capable of delivering what Smith needed. So in 1982, General Motors approached the Yellow Kaiser himself. The result was FANUC Robotics Corporation, a 50-50 joint venture headquartered in Troy, Michigan. The deal was elegant in its simplicity. General Motors would provide the capital, the software engineering talent, and most importantly, the customer. FANUC would provide the robots, the mechanical arms, the servo motors, the controllers, the manufacturing expertise that had been perfected inside the forests of Mount Fuji. A small staff of about 70 people began work at the General Motors Technical Center in Warren, Michigan, and almost immediately, the venture locked onto two applications that would define the first wave of factory automation in America: paint spraying and spot welding. The growth was staggering. Within 2 years, FANUC was selling over 1,000 robots per year and generating tens of millions of dollars in revenue. It vaulted past every domestic competitor to seize the #1 position in the American robotics market, including Cincinnati Millicron, the Ohio-based company that had been the acknowledged leader. By the mid-1980s, roughly 3/4 of FANUC's sales were going directly to General Motors plants. Walk into a General Motors assembly plant in Flint or Pontiac in 1985, and you would see it happening in real time. Where a line of human welders once stood shoulder to shoulder behind face shields, their torches throwing blue-white arcs across bare metal, there were now rows of bright yellow robotic arms bolted to the floor. Each arm moved with a precision that no human wrist could replicate, executing the same weld pattern thousands of times per shift, without deviation, without fatigue, without a break. The sparks still flew, but the hands holding the torch were no longer made of flesh. An entire generation of skilled tradespeople watched their craft become an input variable in someone else's software. The company also developed something that would become one of FANUC's most enduring contributions to the industry, a programming language called Karel, named after the Czech playwright Karel Čapek, who invented the word robot in 1920. Carl was a higher-level language, similar to Pascal, that allowed the robot controller to act as a cell controller, eliminating the need for separate programmable logic controllers on the factory floor. It made FANUC robots easier to integrate, easier to program, and harder to replace. But the yellow arms arriving on the factory floors of Flint and Detroit and Pontiac were not greeted warmly by everyone. The United Auto Workers Union and thousands of American factory workers saw what was happening. Factories that once employed hundreds of human welders were being retrofitted with robotic arms that did not take sick days, did not require pensions, and could operate inside toxic paint fumes without complaint. The machines were faster, more consistent, and they never got tired. Protests and strikes punctuated the era. Workers who had spent their entire adult lives mastering a trade watched as their stations were handed to yellow machines imported from Japan. The economic devastation that followed in the industrial Midwest, the shuttered storefronts, the hollowed-out neighborhoods, the generational poverty, did not begin with FANUC. But FANUC's machines became the most visible symbol of a transformation that millions of Americans experienced as a personal loss. And the tension between human bodies and industrial robots was not only economic, it was physical. The first recorded human death caused by a robot occurred in January 1979 at a Ford casting plant in Flat Rock, Michigan, when a 25-year-old worker named Robert Williams was struck and killed by a 1-ton parts retrieval machine. His family was awarded $10 million. It was not a FANUC machine, but it established a grim precedent for the entire industry. As FANUC became the dominant force in American factories, its own equipment was inevitably involved. In 2015, a maintenance technician named Wanda Holbrook was killed by a robotic arm at an auto parts plant in Ionia, Michigan, when the machine breached a safety divider and entered her work area. In 2023, a robotics engineer named Peter Hinterdobler suffered severe injuries at Tesla's Fremont plant when a FANUC robot's arm and counterbalance weight released during disassembly. Both incidents resulted in major lawsuits naming FANUC America. The machines that made factories faster also made them more dangerous for the people still working alongside them. But while the human cost of automation played out on the factory floor, FANUC's corporate trajectory continued to accelerate. In 1986, FANUC formed a second major American joint venture, this time with General Electric. GE FANUC Automation took over General Electric's existing CNC plant in Charlottesville, Virginia, and began selling FANUC's computer numerical control systems across North America. The move was strategic. With GM FANUC selling robots and GE FANUC selling CNC controllers, FANUC was now attacking the American factory floor on two fronts simultaneously, controlling both the brains and the arms of the machines. Then, in 1992, FANUC bought out General Motors' remaining stake in GM FANUC and restructured the entity as FANUC Robotics North America. The Yellow Kaiser now owned outright the infrastructure he had built inside the American market. No longer tied exclusively to GM, FANUC expanded aggressively into aerospace, food and beverage, pharmaceuticals, and consumer goods. But dominance of this magnitude comes with a vulnerability that FANUC's engineers never anticipated. When one company's control systems run half the CNC machines on the planet, those systems become a target. A 2022 cybersecurity analysis by the firm Trend Micro tested CNC controllers from 4 major vendors, including FANUC. The researchers found that FANUC's FOCAS interface, the protocol that connects its controllers to factory networks, was susceptible to 10 distinct categories of attack, including remote code execution, machine hijacking, and production sabotage. None of the tested vendors had authentication enabled by default. In a world where state-sponsored hackers routinely probe critical infrastructure, the fact that a single cybersecurity flaw in FANUC's software could cascade across factories in dozens of countries is no longer a hypothetical scenario. It is an open question with no public answer. And it was in consumer goods that FANUC secured what may be its most consequential relationship, one that almost nobody talks about. Apple does not manufacture its own devices, but the company is widely reported to be one of the largest indirect buyers of CNC milling machines in the world. To produce the seamless unibody aluminum chassis of the iPhone, the iPad, and the MacBook, Apple's contract manufacturers, primarily Foxconn and Pegatron, purchase enormous quantities of FANUC robo-drills. The robo-drill is a compact, high-speed vertical machining center that can mill, drill, and tap metal with micrometer precision. Reports from the trade press estimate that Foxconn alone was purchasing roughly 800 robo-drills per month at approximately $62,000 each during peak iPhone production cycles. The total number of FANUC robo-drills dedicated to Apple-related manufacturing across China is estimated in the tens of thousands. That means every time you pick up an iPhone, the aluminum shell in your hand was carved from a solid block of metal by a FANUC machine. The robo-drill is just one of 3 product lines in FANUC's robo-machine division. The RoboShot, the world's first mass-produced all-electric injection molding machine, was developed in the early 1980s by Inaba's son, Yoshiharu Inaba, who had studied hydraulic molding at Cincinnati Milacron before returning to FANUC and building a fully electric alternative. The RoboCut handles wire electrical discharge machining, using a thin electrified wire to cut intricate shapes in hardened metals. Together, these 3 machines cover virtually every major fabrication process in modern manufacturing. On the robotics side, FANUC's product line spans from the compact LR Mate series, small enough to sit on a desktop, to the M2000, a massive arm capable of lifting 2,300 kilograms. In 2023, FANUC announced that it had shipped its 1 millionth industrial robot, a milestone reached in roughly 46 years. And in the CNC division, FANUC reached its 5 millionth unit in February 2022, a number so large that it is difficult to contextualize. FANUC's own corporate materials claim a 65% share of the global CNC controls market. No competitor is close. More recently, FANUC has moved into the collaborative robot space with its CRX series. Unlike the caged, high-payload industrial arms that dominated the 20th century, these cobots are designed to work directly alongside human operators, without safety barriers. They use sensitive torque sensors that stop the arm instantly upon any unexpected contact. The strongest model in the collaborative line, the CR35IB, can handle 50 kilograms, giving it the highest payload of any cobot currently available. FANUC paints them with green accents to visually distinguish them from the traditional yellow arms. The message is deliberate. Yellow means stay behind the cage. Green means it is safe to stand next to this machine. In the global robotics market, FANUC competes against formidable rivals. The Swiss-Swedish conglomerate ABB, Japan's Yaskawa and Kawasaki, and Germany's KUKA all contest the same factory floors. By revenue, ABB and Epson each hold roughly 13% of the global industrial robotics market, with FANUC at approximately 11% and Yaskawa and Kawasaki each near 8%. But those figures are measured by sales dollars, not by the number of physical machines deployed. When the count shifts to units shipped, to the actual robotic arms installed in factories around the world, FANUC has consistently ranked at or near the top. 1 million robots in the field, 5 million CNC systems. No other company on Earth has that installed base, and FANUC has been quietly preparing for the next phase. In 2016, the company launched the Field System, short for FANUC Intelligent Edge Link and Drive, an industrial Internet of Things platform developed in partnership with Cisco, Rockwell Automation, and the Japanese artificial intelligence company Preferred Networks. The system connects machines on a factory floor to a shared edge computing network, enabling predictive maintenance, deep learning, and real-time analytics. One application, called Zero Downtime, monitors robots for early signs of mechanical failure before a breakdown occurs. By 2018, nearly 18,000 FANUC robots worldwide were running on the platform. FANUC also partnered with NVIDIA to add GPU-accelerated deep learning, allowing multiple robots to collectively learn a task. Where a single robot once needed 8 hours to learn how to pick up an object, 8 robots working together on the Field System could do it in 1. For decades, all of this was governed from the Yellow Fortress at the foot of Mount Fuji with almost no outside interference. FANUC operated with zero debt. The company accumulated a cash reserve of roughly $8.5 billion. Operating profit margins routinely exceeded 40%, figures that would make a Wall Street investment bank envious. The Inaba family saw no reason to explain themselves to anyone. But in 2015, an uninvited guest arrived. Daniel Loeb, the founder of the New York hedge fund Third Point, acquired a significant stake in FANUC. Loeb was an activist investor, the kind of shareholder who buys into a company not to sit quietly, but to demand change. He publicly praised FANUC's operational brilliance, comparing its engineering focus to Apple. But he aggressively criticized the company's refusal to return capital to shareholders, arguing that a company with no debt and billions in idle cash had a moral obligation to buy back stock and issue dividends. The clash was a collision of two fundamentally different philosophies of capitalism. The Yellow Kaiser's legacy said that a company exists to perfect its technology and protect its independence. Loeb's philosophy said that a company exists to generate returns for its owners. The pressure campaign worked. FANUC gradually began to open up. The company established an investor relations department for the first time in its history, instituted shareholder return policies, and slightly pulled back the curtain of secrecy that had defined it for half a century. By then, however, the original Yellow Kaiser was no longer in command. Seiuemon Inaba had stepped back from day-to-day leadership in the mid-1990s, eventually becoming honorary chairman. His son, Yoshiharu Inaba, born in 1948, had taken his own path to the company. He earned a degree in mechanical engineering from the Tokyo Institute of Technology, then spent roughly 10 years at Isuzu Motors, the truck manufacturer that was partly owned by General Motors at the time. He did not walk directly into his father's empire. He earned his credentials somewhere else first. When Yoshiharu finally joined FANUC in September 1983, his father immediately sent him to the United States, to Cincinnati, Ohio, where he studied hydraulic injection molding near the headquarters of FANUC's rival, Cincinnati Millicron. Within months, the younger Inaba had designed something that would become one of FANUC's most commercially important products, the AutoShot, the world's first mass-produced all-electric injection molding machine. Where every competitor relied on messy, leak-prone hydraulic systems, Yoshiharu built a machine that ran entirely on electric servo motors. Cleaner, faster, more precise. It was a statement. The son was not writing his father's name, he was engineering his own legacy. Yoshiharu earned a doctorate in precision mechanical engineering from the University of Tokyo, and he accumulated over 110 patents. He became president and chief executive officer in 2003, and later transitioned to chairman in 2019. The current global president and chief executive officer is Kenji Yamaguchi. But the family's influence, while less visible, remains embedded in the company's culture and governance. Yoshiharu's son, Kiyonori Inaba, now serves as a senior executive in FANUC's robot division. 3 generations of Inabas have shaped the company. The yellow runs in the bloodline. Seiuemon Inaba died on October 2, 2020, at the age of 95. He had spent 74 years inside the company he built, from the day he walked into Fujitsu Shinki as a young graduate to his final years as honorary chairman. During his career, he received the Joseph F. Engelberger Award, the highest honor in the robotics industry, and was elected a Foreign Associate of the United States National Academy of Engineering. He was known to keep a clock in his research laboratory that ran 10 times faster than normal, a reminder to his engineers that they needed to stay ahead of their competitors. He adopted a German engineering slogan, weniger Teil, which means fewer parts, as a guiding principle for FANUC's design philosophy. And the village he chose as his fortress has been shaped by his company in ways that are difficult to overstate. Oshino Village has a population of roughly 9,700 people, and 1 in 4 of them is connected to FANUC. The company's employees earn an average annual salary of 11.6 million yen, roughly $80,000, placing them among the highest-paid corporate workers in Japan. FANUC provides company housing, a corporate nursery school, a medical clinic, cultural centers, and extensive family benefits. Male employees take childcare leave at a rate above 90%. The village's fertility rate, reported by Nikkei at 1.92, is remarkably high for a country where the national average has fallen below 1.3. Oshino is so financially self-sufficient, thanks largely to the tax revenue generated by FANUC, that it receives zero equalization grants from the national government. It is one of the most fiscally independent municipalities in Japan. And inside the compound, the lights-out factories that opened this story continue to operate exactly as described. FANUC has been running fully automated production since 2001. In pitch-black halls with no heating and no air conditioning, yellow robotic arms build approximately 50 new robots every 24 hours. Automated guided vehicles deliver raw materials to multi-axis CNC machining centers. The machines load their own blanks, cut the parts, unload the finished components, and move to the next cycle. A FANUC vice president named Gary Ziwiol once confirmed it in the simplest terms possible. "Not only is it lights out," he said, "we turn off the air conditioning and heat too. Robots building robots in the dark." That is the logical endpoint of the philosophy that Seiuemon Inaba set in motion when he built Japan's first numerical control system in 1956. Every step he took, from the first pulse motor to the CNC spinoff to the GM joint venture to the relocation into the forest, was a step toward removing the human variable from the manufacturing process. Not out of cruelty, out of conviction that a machine, properly designed, will always be more precise than the hand that built it. The financial results for the fiscal year ending March 2026 confirmed that this conviction continues to pay. FANUC posted record consolidated net sales of 857.8 billion yen, a 7.6% increase over the prior year, with net income of 166.5 billion yen. The company's three divisions, factory automation, robotics, and robo-machines, all contributed. FANUC America Corporation, now headquartered in Rochester Hills, Michigan, opened a $110 million West Campus in Auburn Hills in July 2024, totaling over 800,000 square feet, including what the company calls the largest corporate automation training facility in the United States. In March 2026, FANUC announced another $90 million to build an 840,000 square foot manufacturing facility in Pontiac, Michigan, creating 225 new American jobs. The company now occupies over 2 million square feet in the state of Michigan alone. From a 500-person research team inside a Japanese telecommunications company to a multi-billion-dollar colossus hidden in the forests below Mount Fuji. From a quiet engineer who believed yellow was the emperor's color to a global industrial empire that builds the machines that build everything else. FANUC did not conquer the American factory floor with advertising, with branding, or with public charm. It did it with servo motors and source code, and a level of mechanical precision that no competitor could match and no customer could refuse. Today, whether it is an armada of robo-drills carving iPhone chassis in Shenzhen, a lights-out cell machining parts in total darkness in Michigan, or a collaborative robot working shoulder-to-shoulder with a human operator in an Ohio assembly plant, the rhythm of global manufacturing runs on FANUC's pulse. Human hands still design what gets built, but the silent yellow machines from Oshino Village are the ones that build it. If this is the kind of story you come here for, you already know what to do. Subscribe to Trade Archive. The next one is on screen now.